I should be live right now. Yeah, I will get the Google Doc set up. Um,
A problem for another day. I'm good and cooked. There he goes. Let me get you over to Wolf now.
Thank you for the raid, Theo. Everyone, welcome to the Hello Networking stream. Basically, in this stream, we're going to talk about networking, and we're now in lesson 7. And I can show you guys topics. Oh, welcome to the stream, Kiri. I really appreciate you guys joining here. Yeah, let's start the lesson, guys, since everybody is here right now. There we go. So this lesson is entirely free. It could be possible. If there are any mistakes, if there are any, please feel free to comment on the error. Just let me know. And I hope you all enjoy this lesson. What's up, Ursi Lux? Welcome back to the Hello Network stream. So we're going to talk about HRSP, access control, ACL, NAT versus PAD, syslog, NTP, AAA, AutoSecure, and SNP, version 1, 2, and 3. So HRSP stands for Hot Standby Routing Protocol. Usually in a network, you only have one single router that does the routing of the traffic. And with this special protocol, you're able to put one router in standby and constantly check if the device is still up. And if it's not up, it's going to take over the local or the IP from the router that has gone down. So as it says here, continuity is perhaps the most important requirement in a network. Our routing protocols are all aimed at offer a user an alternative path. For example, if a router fails. The hot standby routing protocol offers a solution, and it ensures that you can make your gateway redundant, and if the gateway fails, another device immediately takes over without any changes to the user. So this means continuity. The network keeps running. Even though we destroy a router, it immediately kicks in and makes sure all the devices remain to have connectivity to the outside world. As here you can see in a simple example within Packet Tracer, you got our PC1 and our switch. And then we have these two routers, router 0 and router 1. And with HRSP, you're able to switch over to another router if one fails. You can use these commands. If you're logged into the CLI, you type in interface FA01. Standby 1 IP, you type in the IP. For standby, the priority. Standby 1 preempt, show standby. And once you configure this one with IPv4, you can try it with IPv6. Okay, that's gonna be pretty easy, guys. Okay, now we will come to access control list. Sometimes you want to add an extra security layer to your network traffic. This is basically where access control lists are used for. Yeah, you see some standard commands you could use, like IP access list, the standard, block DPC. You could also deny an IP address, or select the rule to deny. Select the interface it applies on, and also the access group. For access control, let me see. You have two different types. You have the standard, and you got extended. And the extended just has more options. You, for example, can do different ports or TCP, UDP, or all different kinds of traffic. So here you can see the different options. So for standard, you have list number 1 to 99. For extended, you have 100 to 199. Standard is only on source basis, and extended is on source and destination basis. The scope is block or allow traffic for standard, and for extended, this can block or allow service on service level. Keep in mind, ACL works like a funnel. In order which you enter the rules matters, note every access list ends with a deny all. This rule blocks all the other traffic. So if you have included a block all as the second rule, any rule that comes after it will no longer be executed. so it never gets to that line. And so here you can see a basic network you could try to build and simulate the access control listing. Okay, for NAT versus PAT. For network address translation is a method of allowing multiple devices on the network to share a single public IP address. It's often used to allow devices on a home or a business network to access the internet, while still keeping devices hidden and secure behind a network address translation. We also got PAT, which stands for Port Address Translation. Port address translation is a variant of NAT that allows multiple devices on a local network to share a single public IP address by using different port numbers. PAT is often used in conjunction with NAT to allow multiple devices to access the internet using a single IP address, public IP address. So here you can see this is our private subnet, 192.1.0, and you have the public IP subnet. So 64, 23, 22, 41. Here's Google DNS, and here's some shitty ass web server, basically. Yeah, this is basically how it works. As you can see, the user requests from 192.168.1.2 on port 1025, and wants the index HTML from the web server that we just saw here. This web server, basically. I believe, yeah. On port 80. Then it will ask the router to convert it into a private IP address, into a public IP address. In doing so, it becomes a port limit as well as registered into the NAT table. So it will be stored into the network address translation table. From there, it will go to the web server, to this exact port. It receives the request from the user right here, and then it will send it back. It responds to the request and sends it back to the router, which forwards it back to the user. This is the entire cycle for NAT and PAT. One thing to remember is that our routers maintain a NAT table, even if we use port address translation. This table contains 5 important columns. You have the protocol. The transport is listed here: TCP, UDP, or IMCP. So the Spain transfer protocol or the UDP protocol. Inside global, this is the IP address with which the outside world identifies our workstation, the public address of our net address translation router. Inside local, this IP address of the PC seen within an internet network, so the default gateway basically. The outside local, the IP address of the web server as seen from our internet network, so the address you entered is in the address bar of your web browser. And outside global, the IP address of the web server as seen from the outside of our network. This is always as the outside local address for NAT or PAT application. The command you can try in Cisco is show IP NAT translations, and it will show up like this, basically. You can see the entire chain of translation from network address translation. This is how you can configure it. You can try that in soon. So it's not that difficult. You just have to know the different commands. But it's all for Cisco routers, guys, remember. Some more commands to configure it. We now move to syslog and NTP. Syslogging is important to send your logs to a logging server, which maintains all the actions that have happened on a different device. And it doesn't only apply to Cisco, this applies to Windows, to Linux. Pretty much all devices have capabilities for system logging. For NTP, the network time protocol is just having an accurate time measurement across the network. as you can see here, you have the syslog NTP server, and you got the R1 and R0, and these send the data from R1 to the syslog server to right here. And here you can see how it looks in Packet Tracer, the syslog server. Yeah, there are the commands you can use. Logging on, logging host, where it has to send it to, do show logs, give you the logs. To configure NTP server 192.168.3. It's for the network time protocol, basically. You can also allow the loggings to have timestamps. That's what you use with this command. And do show clock. This command basically shows you the time, I believe, correctly. And now you can see this is the end result. You see timestamp, hostname, and you see the message, which is very useful. Then we will go to AA and AutoSecure. This is generally if you want to manage Cisco devices, you use this. So it authenticates to the Radius server right here. So you can manage it remotely, basically. Oh yeah, and AA stands for Authentication, Authorization, and Accounting Server. That's what's AA server for. SNMP is the simple network management protocol, and it's basically used to remotely configure network devices. So if you're using SNMP, it will remotely push an update and just fixes the router for you, basically. Yeah, this is how it looks in the browser. Yeah, and here you can see the basic configuration you could use to practice it. Here are some of the commands you could enter. SNMP server community read 0. Yeah, I could read these out, but you can try this on yourself, guys. I will put them there. These slides are in the Discord. If you want interested in following along. Yeah, there's not much interesting to tell about SNP, but it basically just allows you to remotely configure Cisco routers and configure the settings, basically. I will just show the slide, guys. Yeah, are there any questions? I know I went a little bit fast right now, but do you guys have any questions? Then I could still answer them, and then we can try to do one of the labs if you guys are interested. Otherwise, we'll just skip that, and we're just going to do something else. So, are you guys there? Stream? Which labs are those? I haven't. Oh, that's no problem. This is for Cisco Packet Tracer. If you go into my server, in my Discord server, you will find the homework section. I will put it in the chat, and you can follow along with all the practice material. I haven't created the practice material for this exact one, but you can easily recreate it using the images in the slides. I can give you the slides as well. Let's give you the slides. I have it in home. Here it is. But there are more slides. There are in total 6 PowerPoints, and they guide you step by step into networking. To basically become a Cisco engineer. Do you also use GNS3? No, I don't use GNS3. GNS3 is not that different from Cisco Packet Tracer. It's more realistic, but just to learn Packet Tracer is much easier. Setting up GNS3, you also need the memory, you need the storage. Yeah, not everyone has the luxury of be able to running something like that. But it will be definitely recommended for like if you're going for CCNP or CCIE. Those are probably where you would use that for. But even then, you can use CML2 or the XCPNG, XPX. There's one more that you could use. But they all basically do the same thing, which is network virtualization or simulation. Um, yes, exactly. What the T3GR4 said. Um, yeah, for CCI, you could also use CML2. It stands for Cisco Modeling Lab. Um, yeah, that one was really easy to install though. It required very little configuration. So if you just want to get going, CML2, it may cost you a penny, but you can get up and running immediately. Any more questions? If you have any. Um, no more questions? Okay, then I will end the stream briefly and then I will get back. That might be the other model. It's okay. It's okay. Don't worry about it. I'm gonna end the stream real quick and change the title. So we can eventually put all these streams I did into a real course people can actually buy for like very cheap. Um, yeah, so we will do that. So I will be back in like 1 or 2 minutes, guys. Hold on.